Okay, in the first part of 8.2, we graphed cardioids and limacons without an inner loop. Now we're going to pick up on graphing a limacon with an inner loop. And those come in the form of R is equal to A plus or minus B cosine theta. R equals A plus or minus B sine theta, which looks exactly like what we did without an inner loop. But in that case, A was greater than B. This time, A is going to be less than B. Now, A and B are still both positive, okay? A and B are still both positive when we are looking at these values. But in this case, A is going to be less than B. So, for example, we have R equals 1 plus 2 sine theta. We're first going to check for symmetry. Now the last two have had x-axis or polar axis symmetry. So let's see about this one. If we check our polar or x-axis symmetry, we do that by replacing theta with negative theta. When I do it here, I have R equals 1 plus 2 sine of negative theta. There's my replacement. That becomes 1 minus 2 sine theta because sine is not an even function. So this fails our x-axis symmetry test. So it's a maybe. We can't discount it, but we don't look for it. We don't use it. Now let's check our second symmetry test, which is our y-axis or theta equals pi half symmetry. We check it by replacing theta with pi minus theta. So that's my replacement for this symmetry test. R equals 1 plus 2 times the sine of pi minus theta. We know we have a sign difference here. So we're going to do R equals 1 plus 2 times sine pi cosine theta minus cosine pi sine theta. And let's see, sine at pi is 0 and cosine at pi is negative 1. So that's going to give me 1 plus, and then this is 0, this is a positive, so plus 2 cosine pi. Now, I have a question for you because, not cosine pi, 2 sine theta, good grief, 2 sine theta. I replaced cosine pi, 2 sine theta. 1 plus 2 sine theta, that's what I started with, so this is a pass. We know we have y-axis symmetry. Now let's do our third symmetry test to check for pole or origin symmetry, and we do that by replacing R with negative R. So I would have negative R equals 1 plus 2 sine theta, which would be R equals negative 1 minus 2 sine theta, which is not the same as what I started with, so this is a fail. We can't totally discount that symmetry, but we can't count on it, we can't use it. So when it sets up my chart, it goes from negative pi half to positive pi half. Why would it choose that? Well, it chooses that because of my symmetry. That pi half or y-axis symmetry, so I only have to do one side. And traditionally, if we're going to pick a half along the y-axis, we pick this right side and then we're just going to reflect it across. So before we've been doing the top half and reflecting down, now we're going to do the right side and reflect it back to the left. Okay, so let's check our points from negative pi half to positive pi half. When we plug points in, what is the sine function value at negative pi half? Well, sine function value at negative pi half is negative 1. So I have 1 plus 2 times negative 1. That gives me a negative 1. So at negative 1, we are at negative pi half. At negative 1, we are at negative pi half. So if I come down here, if I go to negative pi half, then I want to go back up to negative 1. I'm right there. And since I'm reflecting left to right, that stays on the y-axis. at negative pi third, which is here, I have 2 times negative square root 3 over 2, which gives me 1 minus square root 3, or 0.7 at negative pi third. Okay, so at negative pi third is here. I go to negative 0.7. That should be negative. That was a misprint, and I nearly didn't catch it. That is a negative 0.7. That caused me problems last time I graphed this. 1 minus square root 3 is a negative 0.7. So if I go to negative pi third and then I go to negative 0.7, I am about there. And I'm going to reflect that across to here. Okay, negative pi 6. Well, what is my sine function value at negative pi 6? It's negative 1/2. So I have 1 minus 2 times negative 1/2. That becomes 1 plus 1 that should be a plus. So 1 plus 2 times negative 1/2 is 1 minus 2, 1 minus 1, which is 0. Oh my word, I'm so sorry, guys. Just put me on mute. 0 at negative pi 6. So let's do our negative pi 6, and then that's just at 0. That's on the y-axis, so it reflects to itself. It's just right there. Ah, goodness. Okay, so at 0, I end up with 1 plus 0, which is a positive 1. So at the angle 0, I am at positive 1. So at 0, I am over here at 1, and that is going to reflect across over here. Okay. At pi 6, I have 1 plus 2 times 1/2, which is 2. So I'm at 2 at pi 6. So I go up to pi 6 and out to 2. And then over to 2 and pi 6 over here. And then pi third, I have 1 plus 2 over square root 3 over 2. When I add that 1 plus square root 3, I get about 2.7. So a positive 2.7 at pi third. So at pi third, I'm at 1, 2, almost 3. And then I'm over here there as well when I reflect across the y-axis. And at pi half, I am at 1 plus 2 times 1, which is 3. So that is 3, and at pi half, and because that is on the y-axis, it doesn't reflect. Now, this limacon with loop, you see that little loop in the middle. So what happens is I've got a little loop here. I come down a little bit. We didn't do the angles that resulted in these negative values, but you do drop below the x-axis just a little bit on this limacon with an inner loop. One thing that I want to encourage you to use for this section. Now, Desmos.com, I do not let you use a graphing calculator, but Desmos.com is a great way to go check your graphs. Desmos.com, you can plug in your equation and it will show you the graph, and you can check and see if you have it correct. Now, because of that, I want to see charts. When I have you turn in written assignments, I want to see charts, because I know you can just go plug in to Desmos and look at your graph. You're not going to have access to that on the exam, so you need to remember that and not rely on it so heavily that you aren't understanding how to do the graph by hand, okay? All right, our next equation, we've got this one and one more. Our next one is the graph for a rose, a polar rose. Now, how many petals our rose has depends on the integer. Our equation that gives us a rose is going to come in the form of r equals a sine or r equals a cosine of n theta, as long as a is not 0. If n is an even integer, I have 2 times n petals. And if n is an odd integer, I have n petals. Okay? So, here's my equation we're going to graph. R equals 3 cosine 2 theta. 2 is an even number, so I'm going to have 4 petals. I can expect 4 petals on this graph. If I go in knowing what my basic shape is, it's very, very helpful when I do the work. Now, I still want to see you do the symmetry checks, so we're still going to work through those symmetry checks. I'm tired of blue, I'm going to switch. Polar axis symmetry, our x-axis symmetry, where we replace negative theta, or theta with negative theta. This would give me r equals 3 cosine of negative 2 theta, and cosine is an even function. So, yes, we have a pass. We got what we started with, so we know we have we have x-axis symmetry. Trying to say it's an even function. Okay, checking for y-axis or pi half symmetry. Remember, we do this by replacing theta with pi minus theta. This is the one that's a little bit more work. So we would have r equals 3 times the cosine of 2 times pi minus theta, which gives me 3 cosine of 2 pi minus 2 theta, which is that difference, cosine difference identity again. So that's 3 times cosine 2 theta cosine 2 pi cosine 2 theta plus sine 2 pi sine 2 theta. Now, cosine at 2 pi is 1 and sine at 2 pi is 0. So this is the term that goes to 0. So I'm left with r equals 3 times cosine of 2 theta. Look at that. That's another pass. I have y-axis and x-axis symmetry. What about origin symmetry? Well, origin or pole symmetry, I do r replaced by negative r. Now, if I do this type of symmetry, I get negative r equals 3 cosine 2 theta, r equals a negative 3 cosine 2 theta. That is a fail. But, because I already know that it is symmetric to both the x and y axes, that is my definition of origin symmetry. Then it is symmetric about the origin. Remember that we said that a fail doesn't mean no. This fails my origin symmetry test, but because it's symmetric about both axes, we know that that is origin symmetry. Alright, what does this mean? Well, it means we only have to check one quadrant. Because it is symmetric about the polar axis and pi half, we only have to check quadrant 1, and then we reflect all that across into quadrants. Reflect across the x-axis and then across the y-axis, and then reflect all of that down across the x-axis so that we get our graph in all 4 quadrants. Now, remember it's a rose with 4 petals. That's going to be very helpful to us as we go through. Okay, at 0, we've got 3 cosine of 2 theta. Well, 2 theta, the cosine at 2 theta is 1. So that's just 3 times 1, which is 3. So our point is 3, 0. So we come out here and we say 1, 2, 3, right there, 3, 0. And we know that that's going to reflect across here. 1, 2, 3, right there. Okay? We also know that that is going to reflect, well, no, let's just go with that. Okay, pi 6. Pi 6 is 3 times a half, which is 3 halves. So we have 3 halves at pi 6. So at pi 6 right here, we have 1.5, so that's there. And that's going to reflect down at 1.5 here, and it's going to reflect over 1.5 there. and then that's going to reflect down, right? So, okay. And then at pi fourth, we have 3 times 0, so 0 pi fourth. So at pi fourth, we have sucked back up into the origin at all of the pi fourths. At pi third, we have 3 times a negative half, because 5 pi third is over here in quadrant 2, and cosine is negative over there, so that's a negative 3 halves. So we have a negative 3 halves at pi third. So at pi third, we go down to a negative 1.5 pi third. Let's see, pi third is here. We've already gotten that graphed on there. And then at pi half, we've got 3 and negative 1, which is a negative 3. So at pi half, we go down to 1, 2, 3, negative 3, but then that reflects back up, 1, 2, 3. And there is the last of our petals. Now, if I'm just looking at these points, I do not know how to connect them, which is why it's very important to know what shape you are going for. The shape I'm going for is that petal, that rose, that's going to have petals that are equidistant. So I've got these 4 petals for my rose, and that's kind of a sloppy rose. Again, I encourage you to double check your work after you've done it with Desmos to see how you did. Do it after you've done your work, though. Do your best to reason through, because again, you're not going to have Desmos to check your work on your exam. You're going to have to do it by hand. You're going to have to make sure you can work with what you've got. So I strongly encourage you to get used to working with what you've got. All right. Our equation here is what we call a lemniscate. Lemniscate. And a lemniscate comes in the form of r squared equals a squared sine of 2 theta, or r squared equals a squared cosine of 2 theta, as long as a is not 0. So here we go, r squared equals 9 cosine 2 theta, so my a value is 3, because my a squared is 9. When I use my symmetry checks for my lemniscate, when I check for polar axis by plugging in a negative theta where I had a theta, I get r squared equals 9 cosine of negative 2 theta, and cosine is even, so that is a pass. I have polar axis symmetry. And then I check my pi half, my y-axis symmetry, by replacing theta with pi minus theta. So I have r squared equals 9 times the cosine of 2 pi minus 2 theta, because I would distribute that, right? So difference identity again. 9 times cosine 2 pi cosine 2 theta plus sine 2 pi sine 2 theta. I'm going to get this right this time. Cosine at 2 pi is 1, sine at 2 pi is 0, so this adds to 0, and I'm left with r squared equals 9 cosine of 2 theta. I got it right. And again, that checks. That's what I started with, so that's another pass, which tells you that I should pass this third test. If it doesn't, though, it's okay, because I know I have origin symmetry because I have the other two. Let's see if this is going to pass, replacing r with negative r. Well, that would be negative r quantity squared equals 9 cosine of 2 theta, and yes, it sure does. We passed all 3 symmetry tests. So we've got origin symmetry, which means I only have to do quadrant 1. Why do I only do to check these points? Because I have origin or pole symmetry. Okay, cosine of 9 times cosine of 2 theta. Cosine at 2 theta is the same thing if I have 0 for theta, that is going to just be 9. So r, therefore, is plus or minus 3. Square root of 9 is plus or minus 3. All right, 2 times pi 6 is pi third. So the cosine at pi third is 1/2. So this is going to be 9 times the cosine at pi third, which is 9 times a half, or 9/2. And I take the square root of that. So it's plus or minus 3 over the square root of 2, which in my calculator gives me 2.1 plus or minus. Square root, or pi fourth. Well, 2 times pi fourth, because it's 2 theta, which is pi half. So I have 9 times the cosine at pi half, and the cosine at pi half is 0. So that's just 0, square root of 0 is 0. Okay, lemniscate. I've got at theta is 0, I have plus or minus 3. So I've got a 3, 1, 2, 3 here, and I've got a 1, 2, 3 there. I go at pi 6, I'm going to go up and down to just past 2. Past 2 is right there and right there. And then over here at pi 6, I go just past 2 and just past 2. And then at pi fourth, I'm at 0. So what I have is kind of a figure 8, a lemniscate. Alright guys, so those are our last 3 categories of polar graphs that you're going to be responsible for.